everyone, today we are going to study Leetcode problem 887 super egg drop. So the problem is that you are given n floors and k eggs. You can drop an egg from a floor and you need to figure out the highest floor from which you can drop the egg such that it does not break. You need to find the minimum number of moves to do that. So the problem statement is quite simple. Now let's look into how we can actually solve this problem. So as the problem stated that we have a building with n floors starting from 1 and you have k eggs. You can take an egg and drop it from any floor, and you need to find out the highest floor at which you can drop the egg such that it does not break. Okay, so all eggs have similar strength. The whole idea is to find at what height can we drop. So a simple solution can be start dropping from 1, 2, 3, 4, and finally you will reach a floor at which it breaks, and that floor is the highest floor, is the lowest floor from which if the egg is dropped breaks, which means this will be the highest floor from which the egg does not break. But how many moves did we take? For example, if let's say this is xth floor, then you will take x moves, right? So in worst case, if there are n floors, you will take n moves. The problem that we are trying to solve is that we need to find the minimum number of moves in order to figure out this x. Okay, so n moves in case of n floors is not a good solution. So how do we go about it, right? So if you have only one egg, then actually you don't have much option, because if that egg breaks, then you end up with no knowledge. So you have to drop it one by one from all the floor, and with one egg your answer will always be n. But what changes if you have two eggs? So if I have two eggs, and let's say that I have 3 floors, so I can drop one egg from 2. So if I drop the egg from second floor, then what can happen? It can break, case number 1, or it cannot break. So if it breaks at floor number 2, then I know I need to check by dropping it at floor number 1. Okay. But if it does not break at floor number 2, I just need to drop it from floor number 3. So how many moves did we take? One move to drop it from floor 2, and one move in either case, right? So as you can clearly see that this problem is not as simple as it sounds. For example, with 2 eggs and 6th floor, let's see what the solution is. So the solution is that you drop from floor number 3. If it breaks, then the sub-problem is with 2 floors and 1 egg, what is the solution? If it does not break, then you have 3 floors and still you have 2 eggs. So whatever the solution is, right? So, and we are solving the problem for 6th floor, 2 egg, and you have dropped from 3rd floor. Similarly, if you drop from 4th floor, then what will be the 2 states? If you drop from the 4th floor and if it breaks, then you have 3 floors to judge, but you have only 1 egg left. And the other case, if it does not break, then you have only 2 floors left and 2 eggs left. So similarly, you will write states for dropping it from all the floors, right? So like first, third floor, 4th floor, 5th floor, 6th floor, 1st, 2nd, and 3rd. And what are we looking for? So we are looking for max of these two but overall we are looking for minimum. So we are looking for minimum of these entities, right? That's all what we are looking for. So how do we solve it, right? That's the question. So as you can see that this can be broken down into subproblems and smaller subproblems, like 6 floor, 2x can be broken down into smaller subproblems. So let's define a dynamic programming state. So what would be a DP state in this case? Let's say DP of n floors and kx is equal to minimum of 1 plus max of, why did I do 1 plus? Because in one move you need to drop the egg. It may break or it may not break. Max of, so let's say I dropped it from ith floor and it breaks. Then how many floors I have left? I minus 1 floors, and x are k minus 1. Let's understand this again. I drop it from ith floor, it breaks. So how many floors I have? From 1 to I minus 1? I minus 1 floors. How many eggs do I have? I had k eggs, well, 1 broke. So now I'm left with k minus 1 eggs. What if it does not break, right? Then I will have floors above to test. So how many floors are above? There are overall n floors. So dp of n minus I floors, right? These are n minus I floors. And how many eggs are left? Because the egg did not break, so we still have k eggs left, right? And 1 plus because the move that we did, right? So now, what would I range from? So I would range from, as you can see, 1 to n, right? And this is your dynamic programming state, right? Now what would be my base conditions, right? So let's see the base conditions. So dynamic programming DP, so n is number of floors, k is number of eggs. So if I have 0 floors and any number of eggs, then the number of moves I'll take is 0. If I have any number of floors but 0 eggs, number of moves are still 0. If I have 1 floor, any number of eggs, then also I'll take just 1 move because I have only 1 floor. And if I have only 1 egg and any number of floor, that this we have already covered, then the answer would be n. So with these base conditions, we would proceed solving the problem. So let's see, how do we solve this problem? Okay, so as we had discussed, let's proceed. So we have dynamic programming array plus 1, k plus 1, and we need to initialize it for n equal to 0, so then n plus plus. Okay, so what are our base conditions? If dynamic programming of I and number of eggs are, let's say, 0, the number of moves will always be 0. And if there are any floors and I have 1 egg, the answer would be I, because we need to try it from each and every floor. I hope that's clear. Now, what if we have 0 floors and any number of eggs, number of moves will be 0. What if we have only 1 floor and any number of eggs, right? Then also answer would be 1, right? So I have written the base conditions, although it would have been sufficient if we just had any one of the 0 and 1 states, but I prefer writing both. So now let's run the dynamic programming from int I equals 0, I less than equal to n. So remember, now I don't need to run from I equal to 0 because for 0 and 1 I have already solved. Okay, right? So now let's see how we will solve this problem. So as we had written, so the dp state is for any dp of ij, it is equal to min of, as we had seen, min of a range, right? And what that range is, so we'll have one more for loop inside, for int m equal to 1, m less than equal to I, m plus plus. So let's see what are the range of values. We can see that n is 10 to the power 4. We'll just keep it slightly higher than 10 to the power 4. Let's set it to infinity. And now dp of I j is equal to min of dp of I j, comma 1 plus max of dp of m minus 1 j minus 1, comma dp of I minus m and j, right? So if I drop it from mth floor and it breaks, then m minus 1, j minus 1, because the egg broke, so j minus 1. And if it does not, then I minus m floors, and we still have j eggs. So yeah, so this is what we need to do. And at the end, our answer will be in dp of, let's see, n comma k, right? So let's run this. So you can see that the solution is accepted. We'll just submit it. Okay, so we see that this approach, even though it is correct, but the time limit exceeds, and that's why this is a hard problem. And why did the time limit increase, or why did we exceed the time limit? If you see, then our time complexity is n times k times, and this is proportional to I, so that's again n. So it's n square k, and range of n is 10 to the power 4, right? So it's n square k, which means 10 to the power 4 square, 10 to the power 8, times 10 to the power 2, so it's 10 to the power 10, and that's why it is getting time limit exceeded. The solution is correct. You did not fail any test case. It's just that we are exceeding the time limit. So what change should I make? So let's go back to the blackboard and see how we can tweak the DP state a little bit and solve it in a much better time complexity. Okay, so now let's see. So far we studied one type of DP state. Can we change the DP state? Let's see. So now I'm saying that, so initially we had n floors, you had kx, and we are trying to find how much moves are we taking. Now we'll tweak the DP a little bit. We will say that, let's say I have m moves and kx. What is the maximum number of floors that I can scan with this? And what do I mean by scan? So it's basically what's the maximum number of floors for which m moves would be enough with kx to determine at what floor should we drop the egg so that it does not break, right? So let's say that we tweak the DP. So far we had DP of n floor k egg and we are trying to find m. Now we are doing it a little different. We are fixing m and we are fixing k and we're trying to find what is m. Okay, so let's see, can we break it down into subproblems? So dp of m plus k, can we say that if, and now we're talking about moves, so m moves and kx, let's say whatever the answer is, let's say that at the last move that you made, right, the mth move that you made, the egg broke, okay, or the egg could not broke. Either of the cases can happen, right? So if the egg breaks, then you are left with m minus 1 moves and k minus 1 eggs, right? And let's say you are able to span x floors. If the egg does not break, then what happens? You are able to scan, you are still left with m minus 1 moves because the move has already happened, and you're left with kx. So whatever floors, so let's say this is y, right? This is x and this is y. So overall, how much floors are we able to span? So this is the floor itself. So this is x, this is y, and this is the floor from which we dropped. So 1 plus y plus x. 1 plus x plus y, right? So dp of mk would be equal to 1 plus dp of m minus 1 k minus 1 plus dp of m minus 1 k. Okay, let that sink in. So if you have m moves kx, then you can write 1 plus m minus 1 egg k minus 1, m minus 1 moves, k minus 1 x, m minus 1 moves, and kx. Right, we just proved it, because let's say you drop it from any floor, and it can be any floor. Now so the good thing about this state is we are not concerned with which floor. Any floor you drop it, your moves reduces, m minus 1. If it breaks, your egg reduces, and your answer spans this egg. This is the break case. If it does not break, then you need to know how much you are spanning above, and what would that be? M minus 1 eggs, k is the number of eggs. So what I am saying is that dp ij stores the correct answer for I moves and j eggs. So can we say that dpmk can be broken down into this? Yes. And we will code this up and see how we get the correct answer. Okay, so now we use the new approach and we solve this problem again. So we name this super egg drop 1. Let's copy paste this first. Okay, copy paste this code, write it here. It's going super egg drop 1, and this we will implement. Okay, so now what did we say? That we create a vector 2D array. Let's name it dp, and it will have m moves and k eggs. The number of moves can't be more than n, right? We will do n plus 1 for the 0 error, okay, and k plus 1. but this is a vector of vector, so we'll just write vector int k plus 1 comma zeros. So all zeros, right? This is what it means. So you have populated a DP two-dimensional DP array with all zeros, and that's the base case in this. Now, what we need to do is, while DP of M, okay, let's say int M equal to 0, DP of M, number of moves, and this is the number of eggs, DP of mk, while this is less than n, we do m plus plus, and dp of mk is equal to dp of. So here we will need to basically have a for loop, and I'll tell you why. For int, okay, so this is how we will write it, because we need to cover the array from this 2D matrix from the beginning. So initially m is equal to 0, we do m plus plus, and now we are populating basically 1 comma 1 is equal to 0 comma 0 plus 0 comma 1 plus 1. Okay, so this is how we populate it, and the moment dpmk becomes greater than n, you can return m. Okay, so let's see this works. So we can see that it works, right? And we will quickly submit it, and now you can see that it got accepted. Okay, so the previous solution, now let's see it properly, that the previous solution time complexity was order of n square times k, and this is order of n times k, right? N times k. And that's the difference between the two approaches, and that's why this is a hard problem, and this is how we'll solve it. Hope it clarifies. Thank you for joining.